All right, so we have an example problem to work through using the logistic growth equation. So if you remember, our logistic growth equation is used to estimate our population growth rate, dn over dt. And it is r times n times k minus n over k. This also reduces to r times n times 1 minus n over k. And I prefer this method instead of using this method. So our first question up on this board, it says that mosquito fish exhibit an R of 0.75 fish per month. You set up an aquarium that can support 200 mosquito fish. Calculate the population growth rate when you have 3 different population sizes. So the first thing that we always like to do when working with these problems is to write out what's actually given in the word problem. So in this problem, we have R. It is 0.75. We also have the carrying capacity K. This is listed as 200 fish per tank. So we're going to start with our first problem A. We say we start with 50 fish. Now what is our population growth rate? Well, our population growth rate is going to use our dn over dt equation. So dn over dt is equal to this equation, and I'll use this equation. So we have r, that's given in the problem, we have k, that's given in the problem, and now in our problem we have our population size n. So I will just substitute each of these variables into our equation. And once I have that, I will then use my calculator to calculate our population growth rate. Now, easy way, and the reason why I prefer this method, is that I can use our parentheses and just type everything in right into our calculator. So I've got my calculator here. It is 0.75 times 50 times my parentheses, 1 minus 50 divided by 200, close parentheses, and equal sign, and I get 28.125. And to round, we will say this is 28 population growth rate of 20 fish per month. Question B changes our population size. R and K remain the same, but our population size changes. And our new population size is 100. So doing the exact same thing using the exact same equation, we asked what is the change in our population size? Population growth rate, it's dn over dt. It's equal to 0.75 times 100 times 1 minus 100 over 200. And again, I'd use my calculator, use the parentheses to solve this, and I get 37.5 fish per month, which rounds to whole numbers of 38 fish per month. And that's B. C changes our population size one more time, and it is now 225 fish. So we ask the same question, what is our population growth rate? And we start substituting each of our variables. And when we calculate this, we actually get a negative number. We get negative 21.09, which rounds to whole numbers of negative 21 fish per month. Now the question is, does this make sense? And it should make sense. If you recall, our logistic growth equation tells us the growth rates that would produce this type of growth curve, where we have our population size as a function of time, and it's going to grow all the way up to our carrying capacity. If we are below our carrying capacity, if we are down in this area for our population size, our population wants to grow to get up to that carrying capacity, which means our dn over dt is going to be positive, a positive value. We're going to experience population growth. And that happens here in both A and B. Our population size is below our carrying capacity, so we exhibit population growth. If we are above our carrying capacity, then we want to go back down to our carrying capacity. So this area represents negative population growth rates because we're going to see a decrease in our population size. 225, it's above our carrying capacity. We're going to experience negative population growth to get back to our carrying capacity. There's one other point that I'd like to tell you, and that's in this problem, we are at half of our carrying capacity for B. At this population size, a population size of 100, we are at our highest, our maximum value of population growth rate. That maximum value, 38 fish per month. Below that value, we're going to have a smaller growth rate, something less than 38 fish per month, and we see it when we have a population size of 50. We only exhibit 28 fish per month. If we go above 100 fish per month, or 100 fish in our population size, we're going to have a lower population growth rate because, again, half of our carrying capacity is our population size where we exhibit our maximum population growth rate. So this is question number 1. Hopefully it helps you solve our problems and you feel comfortable calculating changes in population growth rate.